Alright, hello. These are our Unit 2, Day 6 notes over imaginary numbers. So every once in a while, when we use the quadratic formula, which is what we learned about yesterday, we get impossible answers. So that's when you have the negative under the square root. So it's impossible to take the square root of a negative. Now, when it happens, we pull out I. Okay, I stands for the square root of -1. So in here, if we pull out an I, we have the square root of 20. I square root of 12. I square root of 500. I square root of 200. So that's what you guys know so far. Now when we're simplifying expressions, I works the same way as variables. Okay, it works the same way as any variables like x. The only exception is I squared. And since I equals square root of -1, I squared equals -1. So let's go ahead and do one of these. So if I'm adding, so I'm just combining like terms. So -2 plus 5, so that's going to be 3. And then -3i plus -2i, so that's minus 5i. I can't combine these at all anymore because they're not like terms. The 5 has an I on it and the 3 does not. So for this one, 4 minus 1 is 3, and then -2 minus 3 is -5. So here we're actually going to get the same answer. Now when we multiply, things get a little different. So 3i times 2 we're going to distribute is 6i. And then 3i times 2i will be 6i squared. Now up here I told you that I squared was -1. So this is 6i plus 6 times -1. Or it ends up being 6i minus 6 as our final answer. Here we're going to distribute twice. So 2 times -3, that's going to be -6. 2 times 6i, it's going to be plus 12i. -I times -3 will be plus 3i. And then -I times 6i will be -6i squared. Now this isn't done. We have some things to combine. So 12i plus 3i, it's going to be 15i. And then we know that I squared is -1. So really this turns into positive 6. So -6 plus 15i plus 6. My 6's are going to cancel, so my answer will just be 15i. So now we're going to work with conjugates. So how do we get rid of the I? When we see imaginary numbers, numbers that have I, there's a thing we can multiply them by, so they're no longer imaginary. This is called the conjugate. So there are two types of conjugates. One, what can you multiply in order to make each of these a real number? So if we just have I can multiply by I. So 2i times I, that's going to be 2i squared. And we know I squared is -1, so 2 times -1, so this equals -2. Here I can multiply by I to get -5i squared. And I squared is -1, so this one just equals 5. Here I can multiply by I to get 14i squared, which is 14 times -1, which is -14. We can also do the conjugate when we have complex numbers, so a real and a complex number together. So with plus or minus, the only difference is we're going to multiply by the opposite. So instead of 1 plus 3i, we're going to multiply this by 1 minus 3i. We'll multiply b by 2 plus 4i. And we'll multiply c by negative 4 minus 9i. So, to solve these, you just start distributing. 1 times 1 is 1. 1 times negative 3i is negative 3i plus 3i. And then 3i times negative 3i is negative 9i squared. Now, negative 3i plus 3i, those are going to cancel. We get 1 minus 9 times negative 1, which turns into 1 plus 9, which is 10. So that's nice. We have a regular number to work with, a real number, not a complex number. So we'll do the same thing here. 2 times 2 is 4. 2 times 4i is 8i. Negative 4i times 2 is negative 8i. And then minus 16i squared. My 8i's will cancel, and I'll get 4 minus 16 times negative 1, which is 4 plus 16, so my answer is 20. Okay, I want you guys to pause the video for a minute and try C on your own. So negative 4 times negative 4 is 16, plus 36i minus 36i minus 81i squared. 36i's cancel, so 16 minus 81 times negative 1, which is 16 plus 81. So the answer is 97. So you may be wondering, why is this even useful? So remember, we are never allowed to divide by 0. Okay? We're also not allowed to do, or a fraction. And remember, when we divide by a fraction, we flip and multiply. It's kind of the same thing. So we're also not allowed to divide by a conjugate. So if you see a complex number in the denominator, multiply by the conjugate. And here's the important part on top and bottom. Okay, so in A, my conjugate here is I, multiplying by I. So this becomes 10i minus 10i squared over negative 6i squared. Okay, I squared, that's negative 1. So this becomes 10i plus 10 over 6. Done. Yes, you could simplify by dividing everything by 2, but I'm not going to worry about that today. Here, my conjugate is negative 1 minus 3i. So I get negative 8i minus 24i squared over 1 plus 9i minus 9i minus 9i squared, which becomes negative 8i plus 24 over 10, because 1, so your 9's will cancel, and 1 plus 10, 9 is 10. Here, we'll multiply by negative 2 plus 6i. So 5i times negative 2, that's negative 10i plus 30i squared over 4 plus 12i minus 12i minus 36i squared. 12i's will cancel. You get negative 10i minus 30 all over 4 plus 36 is 40. We can keep going, but the thing I am most concerned about with you guys is using this to solve the quadratic formula. So that's what we did today. So the first thing we need to check is if our equation is equal to 0. Yes, it is. Okay, now I need my A, B, and my C. So my A is 3, my B is 4, and my C is 2. So if I start plugging in, I get negative 4 plus or minus the square root of B squared minus 4 times A times C all over 2A. So if I make this better, it becomes negative 4 plus or minus the square root of, let's see, 16 minus 24. So that's going to be negative 8 over 6. When you put the square root of negative 8 in your calculator, it's going to say non-real numbers because it is imaginary. So what we can do is we can pull out the negative to make it negative 4 plus or minus I square root of 8 all over 6. And your answers, we can put them in like we've been putting in the calculator, and our final answer is going to have an I attached to it to show that it is imaginary. Okay? It's also okay if you leave them like this for now with imaginary. If you have any questions, see your teacher.